Support for your public radio station comes from our members and from GreenSpark Solar, serving the greater Rochester and Finger Lakes regions for over 20 years. GreenSpark Solar is dedicated to helping people power their homes and businesses with local solar power and battery storage backup. More at greensparksolar.com.
From WXXI News, this is Connections. I'm Evan Dawson. Our connection this hour was made on a distant planet, 120 light years away. For now, the planet is known as K2-18b, and something is happening there. Or at least something was happening there 120 years ago Earth time, I think. I'm not always good at understanding space math. We'll get to that coming up. Here's the story. Scientists who are searching for signs of life have found some. On this planet, scientists have detected biosignatures, or at least in the atmosphere of the planet. Here's how the New York Times put it. Quote, "The search for life beyond Earth has led scientists to explore many suggestive mysteries, from plumes of methane on Mars to clouds of gas on Venus. But as far as we can tell, Earth's inhabitants remain alone in the cosmos. But now a team of researchers is offering what it contends is the strongest indication yet of extraterrestrial life, not in our solar system, but on a massive planet known as K2-18b that orbits a star 120 light years from Earth. A repeated analysis of the exoplanet's atmosphere suggests an abundance of a molecule that on Earth has only one known source, living organisms." End quote. Now, what kind of living organisms? So far, there's no evidence that it's the kind that play Wordle or spend too much money on frothy Starbucks drinks. One of the authors of the study put it this way, quote, "It is in no one's interest to claim prematurely that we have detected life," end quote. And yet, in the same interview, he went on to say that his best guess is that K2-18b is covered with a warm ocean brimming with life. The research team called it a revolutionary moment, the first time humanity has seen potential biosignatures on a habitable planet. Now, science is a tough crowd. Make a big claim, and your colleagues will try to poke holes in it. That's what makes science so rigorous and so great. Stephen Schmidt, a planetary scientist at Johns Hopkins University, told The Times, "It's not nothing, it's a hint, but we cannot conclude it is habitable yet." Astrophysicist Adam Frank shares the same skepticism. He wrote in The Spectator that these findings are not all that momentous yet, but he notes something about it that is momentous. For centuries, all we had were hunches. Are we alone? Is anyone else out there? Is this thing on? Well, now, Frank notes that for the first time, we're debating a specific biosignature claim on a specific planet that we can observe. If you listen to Connections enough, you know what I think. It is aliens. But I figured we should consult the expert on this one. Adam Frank, author, and Helen F. and Fred H. Gowan professor in the Department of Physics and Astronomy at the University of Rochester. Dr. Frank is the author of The Little Book of Aliens, and he is the author of the forthcoming Every Man's Universe newsletter. Welcome back to the program.
It's a pleasure.
It's aliens, right? How many times have you been on the show in the last decade? We're like, we got it. It's aliens. Is this the one, aliens?
So how to frame this, right? Because as I wrote in that article for The Spectator, like there is something truly exciting about this, but it's not the result, because the result itself does not come up to the standards in science, and we can talk about what that is. There's a way of formalizing that. The standards by which we judge, like, oh, that is not noise. That is an actual factual signal. That is not just some randomness, random light particles bouncing around. And the funny thing, of course, was as soon as this came out, I started a conversation with my colleagues and friends who are all astrobiologists, all of them much smarter than me, and they were skewering this result, and the researcher as well. I mean, which is good, because that's what you want. But they had like 1,000 reasons why this was not a biosignature. But that's great. That's exactly what should happen. And we can go into what their objections were. But what matters is that this was, a reputable researcher. Madhu is he's a really good researcher. It was a absolutely top-of-the-line instrument, the James Webb Space Telescope. And so this was like, this is what it's going to look like. It's going to take us, finding life in the universe is going to take us a while. But this is what the process actually looks like. So I don't think this one even comes close to rising to the standards of, yes, we've found life. But it is sort of like, wow, we're actually here now. We're actually going to start this argument. We're going to have data, to start the argument.
You're the worst.
I know.
Scientists just are such buzzkills.
Wah, wah, wah.
In many ways, the conversation this hour is going to be on why it has to be this rigorous and what we can learn from that. But let me just back up and ask you to explain a little bit more about what you wrote in your piece for The Spectator titled "What a Gas." That's probably not your headline. Is that your headline?
No, I
that's
never
a good
get
one.
to choose headlines.
That's
and
a good
sometimes
one.
that's good, sometimes that's bad. Yeah.
That's a good one. But when you point out the momentous part of this to you, at least, obviously it will be very momentous if we get more rock-solid data and every one of your colleagues who's saying, well, it's probably not that because this, or it's not X because Y. And if they can beat all of those holes and solidify this, then it becomes a much bigger deal.
Right.
But I want you to talk a little bit about this idea that for centuries, all we've really been able to do is, be Fermi, gazing up at the sky going like, where is everybody?
Yeah.
And we don't really know. We have no way of knowing.
Right.
And we're starting to get more ways of knowing or trying to know.
That's the revolution that I want people to understand is that, what was it? Saturday night, I slept on my deck. I just went out there and because it was a clear sky and I was just looking up at the stars. And
It was cold, wasn't it?
I had my sleeping bag. I was like ready because I'm a backpacker. So I just went out there with
right.
on my comfortable, couch out on the. But whatever. I was looking at the night sky, and the night sky has always had that mystery, especially if you can get out away from from city lights, and you're just like everybody's always looked at them and been like, what are those? And the question of are we alone? Are we the only place in all those stars where life is formed? It's always occurred to people, like from the beginning. So, the first place you can actually see in history people arguing about this is the ancient Greeks, the Hellenistic Greeks, right? So Aristotle writes that, Earth is unique. There's no place other than Earth. There's, all those lights in the sky, forget about it. Nothing's going on there. And then you had someone like Democritus, who came about 100 years later, who's like, no, every one of those stars in the sky is a sun. They all have planets orbiting them. And you know what? They all have life on them. So, that's 2,500 years ago. And every generation you see people arguing about this. Sometimes the argument heated up, like with Giordano Bruno, where they burned him at the stake for, one of the reasons he was, the heresy he was accused of was about his views. He was saying that, every star has planets on, they're all inhabited. So you see this going back and forth for 2,500 years, but it was all opinion. It was like, bro, it was just like, dude, look at all the stars. There's got to be life up there. And the other guy going, no, life is like really rare. And there was nothing. It was just a bunch of conjecture.
That's all you got.
That's all you got for so long. And, when I was a graduate student in the 80s and early 90s, one of the reasons I didn't go wasn't even called astrobiology then, was that there was nothing to do. There was no science to be done. And then everything changed. And now we're at the point where a guy using the best telescope we have has found a signal in the right place. You expect this signal might to be that, this is what it's going to look like. This is what the process looks like.
Imagine what Bruno and what Democritus would say if they were alive to see this today.
I think Bruno would be like, could you put the fire out? Hey, a little water here because, I was right. Thank you very much.
It's a little late now for Bruno. Sorry, dude.
Water. But yeah, right. For them to see wow, we finally got to the point where we're going to have the process can finally work, the scientific process. And that's why the thing, that we really have, everybody just has to chill. It's going to take a long time. You don't get to answer a question that you've had for 2,500 years, in a day. It's literally, this is going to take decades to work out. And we can go through the whole process. But you just have to sit tight because, we don't have cell phones because somebody just overnight was like, oh yeah, I'll just throw together some pieces of, metal here and look, I got a cell phone. That was 150 years of science that led to your cell phone. So it's going to be the same thing with this, the most important philosophical, religious, scientific question ever asked.
Well, Well, I'm not a scientist, so my standards are lower. So I think it is aliens. But I do enjoy learning about this process. So let's talk about what a biosignature is. Let's start there.
Yeah.
Give me a definition of term there. What's a biosignature?
Okay, so a biosignature. So let's actually step way back. How do we even think we're going to find life, right? So this planet K2-18b, you're right. Somebody should name it like Bob's planet or something. But this planet is 120 light years away. We're not visiting it anytime soon, right? We have no idea how to travel across the stars. So the only way we can tell anything about it is by observing the light that comes from it through a telescope. So what that means is that what we need is we need to be able to look at the planet and look at its light. And then what we do is like detectives, we sort of put the light that's coming from the planet, we put it in the chair and we interrogate it, and we break it apart and we look for signatures or actually fingerprints. It's literally spectral fingerprints in the colors that we see coming from the planet. And every element, hydrogen, silicon, every molecule, carbon dioxide, etc., has a special spectral fingerprint. It only emits or absorbs light with certain colors. That's it, which is a God's gift to us for scientists. So what we're doing is we're looking at the light that's coming from that planet. We're putting it through what we call a spectrograph. We're breaking it apart. And we can check all the colors. And we can looking for places where some of the colors have been eaten, supposedly, by chemicals in the atmosphere that absorbed some of the light. So that's how we can tell, there's carbon dioxide in that atmosphere. Oh, there's molecular hydrogen in that atmosphere. So what we're looking for are molecules that would only be in the atmosphere because life put them there, right? That's what we mean by a biosignature. We're going to look at this planet, we're going to look at its atmosphere, and we're going to see all these compounds, most of which don't come from life. And then we're going to see, hopefully, something that only life could be put there. And now there's a whole process there about what do you mean only life could put it there. But let's take oxygen, for example. So oxygen is kind of like the gold standard on a certain level. Because on Earth, it's amazing, right? When life first formed on Earth, there was no oxygen in the atmosphere, none. And then about 1 billion or 2 billion years later, microbes invented a new kind of photosynthesis. And part of that process was to break water molecules apart, use the hydrogen atom to make a sugar food, and then they farted out the oxygen. And so there was so much, so many of these microbes having this party that the atmosphere started to fill up with oxygen until we finally got to where we are today, 21% oxygen in the atmosphere. It's only there because of life. If life went away tomorrow, if the Earth sterilized tomorrow, that oxygen would be gone. It wouldn't take very long for it to all react up with the rocks. So if we're looking at a planet and we see oxygen in its atmosphere, that is a good bet. That would be a biosignature. Now, there's lots of caveats, and we got to talk about those caveats. But oxygen in an atmosphere would be an example of that's a signature of there being life on that planet.
Is that what they're claiming with K2-18b?
No. What they're claiming with K2-18b is a different kind of biosignature, which in some sense is almost more exciting. It's dimethyl sulfide, which is, don't ask me, actually, they're di, so there's two of something. I guess there's a methyl group, whatever that is. But it's a compound that on Earth is only produced by phytoplankton, by photosynthetic stuff in the sea. And there's so much of this stuff in the sea that actually, Earth's atmosphere has a reasonable concentration. It's low, but would be detectable of dimethyl sulfide. And what Madhu claimed was that they had found the colors, the spectral fingerprint of dimethyl sulfide.
So that's why he's saying their conclusion is everybody slow down. They're agreeing with that, but they're saying that this points that it is possible that there is an ocean brimming with life.
Yeah, so that's a whole other thing if we want to go down that road. This planet, it's not just the dimethyl sulfide. It's this planet. And they've been at the forefront of this, of what would be like an entirely new class of habitable planet, one we don't have in our solar system. So can we just talk about that for a minute?
Well, I thought from what I'm reading, it's much larger than Earth.
Yes.
But watery, kind of like Earth. But are you saying no?
Well, yes and no. Okay, so let's go into it. So in our solar system, there's Earth with one Earth mass. And then there's nothing in terms of mass up until you get to Uranus and Neptune, which are like 14, 17 Earth masses. There's no planets in our solar system in between in masses. Turns out the most common kind of planet in the entire universe is stuff in between there. Either super Earths, which are at the lower range, and what we call sub-Neptunes, which are at the higher range. K2-18b is what would call a sub-Neptune. It is a world that's 8 times Earth's mass. It should be, so is it like a Uranus or Neptune, which are ice giants? They got like a big hydrogen atmosphere, and then it's just kind of like ice and slush all the way down until you get a rocky core. Like, it's not a place for life. But it was hypothesized that the K2-18b was part of a new class of planet we call Hycean worlds, hydrogen ocean, Hycean. And the idea is you've got a hydrogen atmosphere, thick hydrogen atmosphere, but below that, hydrogen is a great greenhouse gas, molecular hydrogen. Below that is an ocean that's 700 miles deep. So for reference, the Marianas Trench is about 6 miles. That's the deepest place in Earth's ocean. So this ocean is, 10 times deeper. And forget, there's no land on this. When your ocean is 700 miles deep, you don't have any continents poking above it. This is an entirely different kind of world that just is like, and the coolest thing was in the first paper. Last year, they published the first paper where they showed that the spectral signatures they were getting were what they expected from models for it being a Hycean world. So they found methane and they found carbon dioxide, and they didn't find ammonia. And that's exactly what you'd expect if this was a world with a hydrogen atmosphere and a giant, giant liquid ocean.
So that's exciting.
That is so exciting. It's exciting because it's an entirely new class of planet that could have life. Like, look, anywhere there's water, we think like, well, it could happen because we think water is important. So this is like an entirely new kind of planet. You don't just have to think about Earth-like worlds, with their nice little continents and little oceans. Now suddenly here's an entirely new class of world that will have liquid water that could have life on it.
A water world.
A water world. Kevin Costner. That movie wasn't so bad. Yes, it was.
Yes, it
terrible.
was.
It's a terrible movie.
Eat your heart out, Kevin Costner. We got a real water world on our hands. So when you are in touch then with your colleagues in the science world who are looking at this going, no, they are finding things that don't add up.
Yes.
Or they think don't add up.
Right.
Like what? What are the holes that they're poking?
Okay, so let's just, as I always like to say, whether we're talking about aliens or we're talking about climate change, scientists are really mean to each other, right? As they should be. Like, so if you want to come out and say something spectacular, like I found aliens, or the Earth is changing because human beings are doing something, you can expect that your colleagues are going to skewer you. They are going to rake you over the coals. Just a sidebar. I did an interview one time with Adam Rees, who won the Nobel Prize when he was a graduate student for discovering that the universe was accelerating. This was like in 1999. And I asked him, I said, that night when you were at the telescope and you suddenly realized, like, oh my God, I've got this data and it shows the exact opposite of what everyone said. Were you like, I'm going to win a Nobel Prize? He was like, no, I'm terrified.
Because you're gonna be pilloried, right? You're gonna look like a buffoon.
He's going to have to stand in front of the smartest people in the universe who are on Earth, who know everything about everything, and they're going to like rip him to shreds. So when I talked with my friends about, and we were going back and forth, they had lots of, well, here's the main thing, right? Scientists, we have a standard for understanding whether a signal is actually a signal. Like, how, there's always noise, right? There's always fluctuations. How do you know whether a signal is you've gotten so clear a signal that it's definitely not noise. So we call this is based on sigma. What do we call it? Is it a 1 sigma result, a 2 sigma result, a 3 sigma, 4? The standard is a 5 sigma, which I always forget because I'm not a probability guy. But I think it's like 1 in a million. Like it's a 1 if you have a 5 sigma result, that says that this thing it's standing above the noise so much. It's so clear that it would be like a 1 in a million chance that you were wrong, that this was actually just randomly, showed up like that. So everybody who knows statistics better than I, you can call in and say like, damn, dude, how could you not know that? Whatever. So 5 sigma is the gold standard. This result, in their first paper last year, they were like at 1 sigma. And they very clearly said like, hey, look, we see some wiggles at dimethyl sulfide, but we're not saying anything. This time they've gone to a different part of the spectra, They're looking at a different regime of colors. And this one's at 5. I'm sorry. This one's at 3.
3.
3 sigma. Now, the world is full of 3 sigma results that went away when you got more data. That's why that's the main thing. Like, look, this is barely at 3 sigma. My colleagues were like, they don't even think it's at 3 sigma. They think that they were optimistic about their evaluation of the. So, lots and lots of times and lots of different kinds of science, 3 sigma results, once you get more data, they go away. Most of the time, actually, they go away. So you don't want to get too excited about that. And then they were like, look, wait a minute. If this is really dimethyl sulfide, then that means there's dimethyl sulfide in the atmosphere, and light from the star should be hitting it and breaking it apart, which means you should see these other X, Y, and Z chemicals. How come those didn't show up in the spectra? So they had this long list of other kinds of things, which is great. This is exactly what we should do. So in general, they were not impressed.
And you are sympathetic to their critique.
Yeah, I think those were good critiques. And that's exactly how the process works. And that's why when we finally announce something, you can bet, that it's going to be, it'll be, and there'll always be controversy, right? There'll always be some controversy. But what will happen is when we get a result that's at 5 sigma, then there's this whole other process that kicks in, which is, validating, making sure other people have to do the observation. But if you really got a 5 sigma result, then everybody would be like, oh my God. But then you have to figure out, is this really a biosignature? Is there really no way to make dimethyl sulfide, for example, naturally, without life? So, it's always going to be an ongoing process.
The likelihood in your mind is right now, we got a cool planet. It's probably not brimming with life, or at least it's probably noise that we're seeing. Do we at least know that it is a water world, though?
I think the evidence that it's a water world is much better than there's any evidence of life. Okay. I think that, again, some of my colleagues are, because I love science so much. Like, they published those papers on the Hycean world, and then other people published other papers. Like, they looked at, now we've got maybe 8 or 9 candidates that are Hycean worlds. And then this is what you want to have happen. Other people stepped in and said, no. Here's the other ways you could be fooled. So let me give you an example of why this is so important. So in my work, I think a lot about biospheres and everything. And you may have heard of the idea of the Wood Wide Web, the idea that forests are alive. There's a green mind, that forests have the ability to communicate. The trees communicate with each other through the fungal networks. So you should think of a forest as being like a termite mound. It's a collective, So that got a lot of press. I love
and
that.
Trees can share resources.
Right. Yeah. Right. So I love this idea. I want this idea to be true. But, those are the ideas you should be most suspicious of because you want them to be true.
Motivated
and recently,
reasoning. Yeah.
Some people have begun to push back on it and be like, no, And I'm like, thank God somebody's pushing back on it because I don't want to be fooled. Right? This is the whole point of science. I don't want to believe something, and especially because I want it to be true, then go down the primrose path. So great, people are now beaten on it, and then we'll see eventually where it goes. And this is why, especially in this world, where we are right now, where expertise and science is just getting hammered on, man, you will pay a price if you give up this method. Because then there's nothing to believe. You have no way of knowing whether anything is true or not. So at least in its domain, the rigor, the nastiness, the sort of wait a minute, of science. That's why we live in the world we do. We have these miracles of science.
And can you correct my math if I was wrong at the start? I mentioned that this planet, K2-18b, is 120 light years away. So
I think it was 124.
Okay. Is that what it is? 124?
That's what I read.
124 light years away.
Just want to throw that
I don't need you to be pedantic.
I'm a professor. I'm supposed to be. I'm paid to be pedantic.
Yeah, that's right. You're a professional pedant. 124 light years away. Now, for a moment, let's assume this is an actual biosignature and that there's life in these oceans. Was I correct to say that what we are seeing then is not what's happening right now, Earth time? What we have would be, if we could verify the biosignature, evidence that, at least in our time, 124 years ago, there was life there. We don't necessarily know exactly what's happening today, Earth time. Is that correct?
Yeah, it's exactly right. Yeah, the light left K2-18b around 1900.
Okay.
Our time. Yeah, so it's
1901, sorry.
Oh, Mr. Pedant.
Gotcha. So if the light left in 1901, and if there's anything that's moving quickly, we know evolution doesn't happen very quickly, so probably, but at least in Earth years, there's probably not much change, but who knows? Who knows? And the point is, we are getting data that, by our standards, is more than a century old. That's very interesting to me.
That is. It's very cool. And, if we were looking at, and eventually we'll be able to do this, if we were looking at the other side of the galaxy is about 100,000 light years, So you'd be seeing stuff from 100,000 years
Our
ago.
own galaxy?
Is about 100,000 light years across, yeah.
How big is this universe?
That's just our galaxy. The nearest galaxy is Andromeda, and I think that's like 700 million light years.
Every
Is that right?
time I
700
talk to you about the size of the universe, I feel like Ted Lasso when he was like, "How many countries are in this country, man?" It's just massive.
Yeah, it's not 700 million. It's 700. I got it.
I'm not going to hold you to it.
Yeah,
It's
thank
big.
you. I'm blanking today.
It's big.
This is me getting
It's
old.
hard to get your head around the size.
But
of it.
Andromeda is the nearest galaxy, and and again, it's like it's on more maybe on the order of 1 million light years away. But then there's literally almost uncountable galaxies.
Alpha Centauri is in our galaxy.
Alpha Centauri is the nearest star, and it's about
Four, three.
It's 4 light years. Yeah, it's about 1 point something parsecs. It's about 4 light years away.
Okay, but it's in our galaxy.
It's in our galaxy.
Is 120 light years away kind of close in the
it's
universe?
the neighborhood.
It's in the neighborhood.
It's on your block. That's how big the galaxy is, right? And how dense with stars. There are 400 billion stars in the galaxy. So across 100,000 light years. So basically,
Not in the universe, by the way, the galaxy.
this is the galaxy, and every galaxy has 100 billion stars, and there's uncountable galaxies. I mean, this is why I got to tell you, folks, no matter what happens in the world, I know the world's a mess, but astronomy helps, right? It just puts things in perspective. Like, things can be terrible, but just remember, it's a big universe with a lot of stories, and our story is just one of them. So for me, I find that a little bit comforting,
I think that's very comforting. I love that idea. We're talking to Adam Frank, who is the Helen F. and Fred H. Gowan Professor in the Department of Physics and Astronomy at the University of Rochester. He's the author of a number of books, including The Little Book of Aliens and the forthcoming newsletter, the Everyman's Universe newsletter. What's that, by the way?
Everyman's Universe is going to be basically, it's a newsletter, so that's the new format. Which the great thing about newsletters is, it's really, people are like, what is that? It's like, well, it's like Blog 2.0, but really what it is you're being freed from the platforms. Like, I don't have to go to like X, which I don't really want to use anymore, and I just don't like social media very much. Basically, if you subscribe, you get, my writing. I'll probably do something each week, maybe a couple things, thoughts on all kinds of things. And it will, like I said, a couple times a week, it'll come to your email box. And I want, what are the things I'm interested in? I'm interested in life in the universe. I'm interested in the human future. I'm interested in climate change. I'm interested in a lot of pop culture. I play a huge amount of video games. I love Andor. I'm just watching Andor. So a lot of, it's a lot of nerdcore as well as, stuff about the science, the politics around science. Like I said, the human future, where are we going, etc.
I have a lot of really good questions from our listeners. And on the other side of our only break, what we'll do is we'll put them to Adam Frank, who is one of our favorite semi-regular guests here. We love talking about science, deep space, tech, biosignatures, and the like with Adam, the search for life, although he's thrown a wet blanket on this one. But I think we're getting caught up to speed on just how close we might be to actually detecting aliens of some kind. If you listeners have a question, comment, you can email the program, connections@wxxi.org, connections@wxxi.org. You can call the program toll-free. It's 844-295-TALK. It's 844-295-8255. It's 263-WXXI if you're calling from Rochester, 263-9994. And if you're watching on YouTube, hello, you can join the chat there. We'll get questions on the other side of this break. Let me also mention, it is a very important week for WXXI and your public media. This was a regularly scheduled membership campaign week, a pledge week. It really matters right now. I don't need to go into depth or spend 10 minutes talking about it. You've probably heard about some of the headwinds facing public media because of national funding priorities or deprioritization. And so, not to make it political, this is not meant to be political. We're just looking at reality. And what we are looking at is a very, very hard go if some of what has been discussed holds up in court or passes Congress or what have you. So some of your public media in smaller areas of the country could go away entirely. And some, like us, I don't think we'd go away, but I'm sure we wouldn't go away, but it would hurt a lot And nobody wants that. Not now, not ever. So what we're asking you to do is jump on wxxi.org/give. And I hope you will. I hope if you are already a member, that you know how much we appreciate it. And I hope if you are not, that this would be a moment for you to do that. wxxi.org/give. Thank you very much.
There are lots of ways to support WXXI. Your old car, truck, RV, or boat can be turned into support for independent journalism and great music. When you donate a vehicle to WXXI, you're directly helping to fund the programming you love. For more information, call 1-877-308-2408 or go to wxxi.org/car.
This is Connections. I'm Evan Dawson. If you're just joining us, wherever you are, however you are accessing your public media, we're talking about some pretty serious headlines from about a month ago that, if you missed it, I know there's a lot going on in the world. You might have missed the news that we found aliens. We didn't find aliens, but 120 light years away, there is a planet known for the moment as K2-18b, and it's in our universal neighborhood, so to speak. It's not that far away. And it is emitting what researchers are saying could be a biosignature, an indication that life could be on that planet producing and interacting in ways that create the chemical signatures that are detectable through our modern technology that tells us there's something beyond just rock here. There's something beyond just typical planetness, that there's life of some kind. Now, scientists across the scientific community have said, not so fast. Let's try to poke some holes in it. But that's going to take some time. And it's pretty exciting to start looking at a specific claim in a specific place in the universe to say, I think that may be life. Very specific. Not, what if. It's let's look here, let's study here. So they're going to keep studying. Really interesting and exciting stuff. As Adam Frank, our guest, astrophysicist Adam Frank, is here, as he has explained, this looks like a
Hycean world.
Hydrogen
ocean world.
A hydrogen ocean world, a big, big water world where there's, it's bigger than Earth, but it would be really interesting if this were correct. So they're going to study this, and we're talking about the process. And I have a lot of good questions, and let's work through some of them now. So Alex sent a note asking, is there a difference between biosignatures and technosignatures?
Yes and no, right? So a biosignature is evidence that there's a biosphere there, that there's enough life vibrant enough that it's pumping enough chemicals out that you can see them from across, interstellar distances. A technosignature is indication that there's a technosphere there. We have a young technosphere, right? Technosphere is all of the industrial processes, all the machinery. It's the satellites. It's everything that a intelligent technological species produces. And what's amazing, and this is what climate change is all about, once your technosphere becomes powerful enough, just like a biosphere, it starts to change the planet. It starts to actually change how the planet functions, and it actually change what's visible. So a technosignature would be something like chlorofluorocarbons. Like we've emitted enough chlorofluorocarbons into the atmosphere that this is a paper that we did. We showed this, that you'd be able to see it across interstellar distances, even from as much as 100 light years away. So technosignatures, and there's a whole list of technosignatures. I'm the principal investigator on the first NASA grant to ever look for atmospheric technosignatures. And the thing is, so they're different because you think it's intelligent life, but really, what does it matter? Intelligent life, not intelligent life? It's just all life changing its planet, and that's the important part.
It's like light pollution in deep space. I mean,
that would be actually city lights. Thomas Beatty did a great paper that showed that actually city lights, if your cities are big enough, you would actually be able to detect artificial illumination on a planet.
Okay, so that's a technosignature. Alex, great question, by the way.
Great question.
Yeah. And when we talk signatures, we're talking about planets that may have life and are showing you somehow. So biology, technology, whatever the case may be. One of the reasons that Adam Frank and his colleagues are going to look at this new claim with a lot of skepticism right out of the gate is there's a lot of history of optimistic claims or big claims or maybe claims that end up being, there was a bug on the lens of the camera. and that was the story almost 10 years ago with Tabby Star. Tabitha Boyajian was a postdoc at Yale, and her team was looking at the light coming from many different stars. And this one I think was 1,200 light years away, if
Could
I'm
have been.
remembering.
I'm not sure.
Something
Yeah.
like that. So not, again, in the universe, still close.
Still
but-
very close. 1,200 light years is still the neighborhood.
Yeah.
Like maybe it's across the street.
But
How about that?
what they saw was the light would dim around this star in big ways. So you'd get light, and then all of a sudden, for X amount of time, 80% of the light would be gone. So it's like something is blocking the light, but it's consistently doing that at intervals. Is whatever's blocking the light rotating around this star, which is what made people think, oh my gosh, we found a Dyson sphere, which is like this idea that a super technological civilization, more than Words with Friends and Wordle, but like super technological, that wants to travel from star to star or planet to planet, would need to harvest the energy of its main star. And so you build this big array of technology around this thing, and it sucks the energy out of the star. That's a very technological, correct term. and it rotates around, and people are like, well, that's it. Look, it's this Dyson sphere, and that's why the light is dimming. And as I recall, it turned out to be space dust or something.
It was space dust, yeah.
It was dust.
But again, that was really a Tabitha star or Bourgeoian star was a real milestone, because what happened is they saw this, and it was just didn't make sense. You were getting, actually it was irregular. It would like bleep, it would go out, and then bleep bleep bleep, it would go out again, and then in a way that it definitely was unlike it wasn't a planet for sure, which is very regular, orbits very regularly. And what happened is that they wrote a paper on it, and they said, what could this be? And they made a long list of astronomical things. And at the end they said, well, it could be a technosignature, and no, well, okay, sure. Like it wasn't like, that's crazy, you can't put that in a paper, that's nuts, no one's allowed to say that. It really broke the taboo about talking about technology.
Because they didn't say, we think it's this.
No, they
said, in the world of possibilities,
Yep.
on that list,
Yep.
if this thing, if a Dyson sphere exists, and even if it's like a decayed shell of it and a civilization
Or swarm.
gone,
They call it a Dyson swarm. Just
okay.
lots of lots of giant
Yeah.
orbiting. Yeah.
So if a Dyson swarm exists, it might manifest like
Right.
this.
Right.
And so we're going to put this on the list of possibilities. The media picks it up like, woo, it's aliens.
I know everyone. Alien
I
mega
did.
structures.
I did.
Next
I
day.
for sure did. Yep, I did. I did that. And then science did its job.
Yeah.
And so it was a buzzkill, but it was really interesting to watch that process.
That's why I really want people, like, it's what we're talking here is like 20 or 30 years. Like before we're really at a point where we can, in 30 years or so, what's going to replace the JWST? The idea is the Habitable Worlds Observatory, the HWO. This is going to be a giant telescope whose main job, who's designed, optimized to find life on other planets. So that's probably 20 or 30 years away, though we have to say I'm a little bit afraid that we're never going to build it. The Chinese are going to build it. But that's another story.
Let's get back to that in a second.
Yeah,
because
somebody's going to build it.
somebody's going to build it.
Somebody's going to build it. And
We have so many calls and emails,
Okay.
Adam, that I'm like overwhelmed now.
Go
So
ahead.
so
Go for it.
I don't want to interrupt you.
no, interrupt me.
I just want to get
Okay,
back to
please
that at
interrupt
the
me.
end, because a whole other conversation with Adam is coming in the weeks to come
Right.
about where science is right now. I'm sorry, where is it again? Okay. We'll get back to that. Mike in Rochester. Hi, Mike. Go ahead.
Hi, how are you?
Very good.
I don't want to throw a wet blanket on this discussion or anything because it's very exciting to me. But I think most people have to. It'd be nice if people had the perspective. It's not just how close they are in space, but in time. I mean, our civilization is just a little blip in time, and we're seeing, so everything's out of phase, and you wonder, you're going to catch a civilization that's blipping at the same time as us. That adds another layer to the difficulty. Anyway.
Yeah,
great stuff.
no, that point is on the money. That's what Frank Drake was asking about. That's when Adam Frank updated the Drake equation. It's like we're not just looking for a neighbor that's technological like us right now. It's like, has it ever existed?
Yeah.
Because it would be kind of hard to line it up.
Yeah, that's the thing. No, it's a great point that you make. It's time. And again, but that's for civilizations, right? Because the thing is about the Earth's biosphere has been around for 3.5 billion years. So biospheres last a long time. We know that from our one example. Technospheres, it's anybody's guess. Like the way we're getting now, I don't know. But you literally would need technospheres to last millions, hundreds of millions of years for there really to be a significant overlap in time. So it's a great point you're bringing up for technospheres or technosignatures.
Yeah, thank you, Mike. I mean, when I think about the time scale, it almost breaks your brain how unlikely it would be to line up two technological civilizations in proximity enough to notice and communicate with each other in the universe. Although, who knows? I mean, there's bigger things than my brain can handle in terms of the possibilities, and that's what they're working on. So thank you, Mike. Great stuff. Hal in Dansville on the phone next. Hello, Hal. Go ahead.
Thanks for taking my call. First, I want to get out there that I'm a big supporter of WXXI in the U.S., and I'm a sustainer of both,
Thank you, Hal.
especially in these uncertain times, which is related to the science. That is, as a background in science myself, I know projects can't be started and stopped, hitter jitter. So that's another troubling thing about the instability of our federal system right now. But getting to the question I had, which is related to Carl Sagan's book and then the movie Contact, where Jodie Foster plays Ellie, and magically she drops through the sphere, and she has an experience of kind of mentally teleporting when everyone on Earth who watches this thinks nothing happened. So, in other words, the problem of distance and time is so overwhelming. And I'm a Star Trekkie type dude, but I know, sorry, a truck's going by. You can't just overcome with some super ultra warp drive distances. So, aren't we kind of stuck with wondering forever about aliens? That's the question.
Yeah, I mean, Hal, I'm going to let Adam respond, although I will remind Adam Frank that on a past program I asked you what's one of the hardest things for you to kind of reconcile in your science brain that we may never get an answer to. And you said it was the question of life elsewhere. We may never.
Well, yeah, I mean, it depends on sort of whether or not they're like, let's say we just keep looking and we never find a biosignature. Does that mean there's no life anywhere? No.
Because then like we're seeing the whole universe.
Exactly. So, but what we will find, that's what I mean about 50 years or so after the Habitable Worlds Observatory, we'll start to be able to put limits on how often they are, right? Either there's life everywhere. And again, I want people to sort of put away intelligent life. Forget the triangle-shaped aliens. Finding a microbe, or a biosphere made only of microbes would be the most significant scientific, philosophical, religious discovery in the history of humanity. It doesn't need to be aliens that you can talk to. Life is so weird. It is so different from anything else in the universe that finding one other example of life in the universe would mean that we're not alone. I mean by life, that we're not a one-off. We're not a cosmic accident. That life is something that the universe does and does everywhere. And because life creates, you have no idea how far it's gone.
Yeah. And I think there are times where even I fall into the trap of going, well, what if it's just microbes?
No, microbes are awesome, man. Do not diss microbes. And it would just, again, it's this idea that because life is creative, it's the only true creative force in the universe. Like stars do exactly what stars, I can predict any star, what's going to happen to it. Not in detail, but its overall lifetime. If you get my standard joke, if you give me a cell and ask what's going to happen in 3 billion years, I would never say a giant, rabbit that could punch you in the face, i.e. a kangaroo. Like evolution is open-ended. It is creative. So just finding one other place where life has formed means that it's probably happened all over the place. And then where and what has it done? How far has it gone?
Thank you very much, Hal. So let me just work as fast as I can through other questions that have come in. Matthew on YouTube, a couple questions from him. Does K2-18b orbit a giant star?
No, it orbits a dwarf star. It's actually orbiting an M dwarf star, which is like the most common. It's people are always like, oh, the sun, a common star. It's not actually. The sun is relatively rare. The most common kind of star is about half the sun's mass, and these are what we call red dwarfs. So they're very different kinds of stars, and the planets that orbit them also will be very different. So yeah, this is because there's so many of them. That's really where our focus is going to be on for the next few decades, is on these M dwarf stars. And that's, some people are like, that's a bad idea, but whatever. That's where we're going.
Matthew had wondered if K2-18b is a super-Earth or a sub-Jovian planet. We think it's a High-Cean planet.
Well, it's a sub-Neptune, not Jovian, because Jupiter's huge. There's the gas giants, Jupiter and Saturn, and then there's the ice giants, Uranus and Neptune. And they're much smaller. They're, like I said, around like 17, 14 Earth masses. So this is K2-18b is sub-Neptune.
Okay. And he's also wondering about the James Webb Space Telescope. He says it can look beyond the universe, maybe the galaxy, but he says, what do you think about this James Webb Space Telescope searching for the aurora on Jupiter's North Pole?
Oh, yeah, sure. Yeah, Hubble did that. You can see the aurora. You can see these storms, these electrical storms happening on other planets with these telescopes. It's amazing.
Stephen writes in to say, hearing that Adam Frank likes to play video games, I was wondering if he's ever played No Man's Sky.
I have played No Man's Sky. I don't like it because it's a little too cartoony about it. I played for way too long. I'm embarrassed to say how long I spent in Elite Dangerous, which is a much more, in terms of just the physically realistic galaxy. So spent hundreds of hours in Elite Dangerous and made it quite far. Thank you very much. I was a bounty hunter of repute. Thank you.
I'm proud of you. Dallas wants to know about 700 miles of water, which is, again, what K2-18b may have if some of the observations or the analysis is correct. He says at that depth, the water becomes ice via pressure. Is it cold? Is it like warm ice? Do you think our planet's core is molten iron in a plasma state? Does the Gleisberg cycles trend mean increasing auroras? He's losing me. Is he losing you?
That's a lot of questions. No, I understand. I can't answer them all. Let's just focus on the oceans. And it is true, 700 miles is so deep that the bottom of the ocean is going to be this ice mix, or also calthrates, which is a whole other. We don't really. I mean, that's why it's challenging to know whether planets like this could have life, because on Earth you really need the thermal vents, the deep sea vents where magma is coming up through the rock, and that provides heat and chemicals to get life on the sea bottom working. At 700 miles, it may be that's impossible. You can't really be in contact with the rock. So, we've spent a lot of time thinking for technosignatures whether you could get a technological civilization in a pure ocean world. But just even whether or not you could get life on a pure ocean world is also open for debate.
I literally was like, it's a pure ocean world. It's going to be like Max Dolphins. Who cares? Again, terrible way to think of it, right? Terrible.
Well, we just don't know. I mean, it's possible, right?
But that would not be a disappointment to you at all.
No, I would love Max Dolphins.
I mean, like dolphins at best. It's not going to be like.
Oh, well, no, I think by Max Dolphins. Oh, I thought you meant like maximized dolphins with like robo brains and,
Yeah, right.
That's where I was going with Max Dolphins.
Yeah.
I don't know what you meant. You meant at Max Dolphins.
Yeah, at best.
That would still be amazing.
It would be amazing.
Yeah.
Patrick says, what should we think of a world where there is a Dyson sphere orbiting a planet? Is that a new form of littering? Yeah, there will be protests against that for sure, Patrick.
By the way, the Dyson sphere goes around the entire star. It's not the planet. You have to build. I'm a little skeptical about Dyson spheres, about whether anybody builds them. We can talk about that, but yeah, it's the whole. You have to basically chew up your entire solar system. Every planet has to go into constructing this thing.
Very hard to do. Big task. Michael says, I have a question. I'm fascinated by the mind-boggling fact that we live in this vast, infinite, expanding universe. I want to learn more about the universe. I don't know where to begin. Any suggestions or advice?
Well, there's infinite documentaries on. I would, go on to Prime and type in astronomy documentary. That would be a great place. There's so many great, and just look for things that you like. You can also follow Everyman's Universe, soon to be appearing. Because I'll be talking about a lot of this stuff. But really, there's lots of books, lots of YouTube has lots of great resources. David Kipping, I love David Kipping stuff. There's one PBS, it's called PBS Universe, PBS Spacetime. Guy from CUNY does it. It's awesome. So, yeah.
All right, do this one in 30 seconds or less if you could, because there's one other thing I want to ask you about. My colleague Katie says, when Adam says scientists are reading the spectrometer data, are they actually doing that with their own eyes, or are AI models doing the reading of this now?
No. We have, it's computers doing it. It's not AI models. There may be some machine learning and such, but it's not AI models. Basically, what happens is, we get the data, the raw data from the telescope. It goes through all kinds of computer analysis, and then you do actually look at it. You actually look at like the spectrum, like, oh, there's a wiggly line over here, and then you may do more analysis of that. But yeah, you do actually look at it and be like, oh, look, there's something right there.
Tom says he would pay for a course taught by you and me. You can't afford it, Tom. It's very nice.
Wow, are we real? Is that where we're going? Hey, man, with the way things are going, maybe that's the way everything should be.
Yeah.
You don't want to pay, you can't see it. I'm sorry.
Commoditize everything. So in our last minute here, I mentioned that we are going to soon have a couple more conversations with you. We've talked to your students in the past about what it means to be a scientist. We're going to keep that series going. And we're going to talk about the state of science research in general. And it's a tough time. And I just want you, in this last minute, to leave with listeners something that you told me before the program, which is that it is by no means guaranteed that a society will be the science leader forever, and there's some examples to that.
Yeah, exactly. I'm working on a piece right now, which I hope will be in the Atlantic, about just exactly the fact. It's very difficult to become a global leader in science. It's very easy to lose it, and there are lots of examples. Look, in 1500s and 1600s, Italy was the world leader in science. In 1700s, Italy was not the world leader in science. In 1900, Germany was the world leader in science. In 1955, Germany was not the world leader in science. And so, the United States has built the most a successful scientific effort ever in the history of the world. And we are definitely right now putting that on the table. And there's other countries which are just like sitting there waiting to eat our lunch, they're looking at what we're doing going like, okay, come on over. So the brain drain is already beginning.
Okay. That's an optimistic note.
I'm sorry. That's what's happening. Yeah. That's like, I'm kind of astonished. Like, why are you breaking something that has led to incredible amounts of prosperity and security? Like, why are you breaking it?
Listeners, if you want to sign up for Adam's forthcoming newsletter, which starts maybe sometime next month, the Everyman's Universe newsletter, how do people find that?
Probably by going to either my website, adamfrankscience.com, and they'll be on right. You can sign up for it there because you got to sign up for it.
Good luck with that. Have fun with it.
Thank you.
And come back soon.
I absolutely will.
We always appreciate it. Adam is the author of many books, The Little Book of Aliens among them. He is the Helen F. and Fred H. Gowan Professor in the Department of Physics and Astronomy at the University of Rochester. More connections coming up in just a moment.
This program is a production of WXXI Public Radio. The views expressed do not necessarily represent those of this station, its staff, management, or underwriters. The broadcast is meant for the private use of our audience. Any rebroadcast or use in another medium without expressed written consent of WXXI is strictly prohibited. Connections with Eben Dawson is available as a podcast. Just click on the Connections link at WXXInews.org.
Support for your public radio station comes from our members and from the Highlands at Pittsford, an independent and assisted living community affiliated with the University of Rochester, offering cottage and apartment homes, daily life enrichment activities, and care assistance as needed. More at highlandsatpittsford.org.
At NPR and this station, we're not beholden to anybody but you. Public media is central to our democracy and our